Alright guys, welcome to the third video of this week's paneling tools. So this is the last file, should be called PtExample03, begin. Okay, so straight off in the corner, and there's not that many here, straight off in the corner you'll see one of these, and before we kind of dive into this, let's just use the normal PtPanelGrid command. And use this to just kind of look at and see what sort of density you're getting here. So with this box pattern, for example, right? With this box pattern, you're getting this sort of density, but when you start changing it up, if you click on the box pattern, you can say, okay, this is a different kind of box that's going diagonal. These are a lot of your options, right? This is a triangular, tri-basic, dense, which is the smallest possible subdivision, diamonds, a diagrid, right, angled box, wave, right, and a brick pattern. Okay, so these are some of the default patterns that come with it, basically, and if you complete it as we did earlier, then you get all the options, right, adding faces, borders, blah blah, all those things. So this is what comes with the normal, let's say, PtPanelGrid. But let's say, for example, here you're trying to do like this brick pattern, and this isn't dense enough, right? You need it to be a lot denser. Okay, so that's where this command comes in, PtChangeGridDensity. So PtChangeGridDensity, it asks you to select a paneling points grid, enter. And then increase, decrease, blah, or same, right? So increase, these should be the defaults, right? Group, yes. And then delete input, no. Just so we still have the original here, right? Enter. You can see it basically doubles it, right? So compared to the original, it interpolates and gives you basically double the density here. Right, and that's what's basically eventually goes over there, and we can sort of actually just test that and see, right, because this is the denser grid. So if we do PtPanelGrid, just a normal one, and then select the dense grid, enter, base surface. And so you'll see this is a lot denser, and especially if you, let's try the brick pattern. So the brick pattern is a lot denser than before, right? So that's kind of how, if you do not want to kind of redo the whole, creating a panel grid sort of thing, this is a quick way to kind of just change the density of the grids automatically, or as a sort of factor of each other. Okay, so that's that. Okay. So the next one you have here is all basically a kind of densified version as well. However, this one, this command actually allows you to manage or create your own 2D patterns. And this here is sort of a representation of what eventually you will need to draw with this sort of grid in line as well. Okay, so what we're going to do is to try this. PtManage 2D patterns. Okay, and then let's click on new. Okay, click new, grid origin point here, and then x-axis reference point should be 1, so it's a 1x1 grid, right? The grid width and height, you'll have to look at this reference, but basically it's 1, 2, 3, 4 for the width. 1, 2, 3, 4, and then 1, 2, 3, 4, 5 for the height. Actually, one more, 6. And 5 for the width. So 1, 2, 3, 4, 1, 2, 3. So I'm basically trying to match it to this, right? Okay. So now I can draw basically a hexagon pattern like I'm showing you here. And I'll draw a hexagon that comes back on itself, basically. Okay, and right click to finish it, right? Now you'll see that the shift is not enough because the pattern is sort of overlapping or doubling back on itself, right? So that's where you have to kind of play around with the shift U and shift V. So the shift U goes from 1 to 2. Okay, that starts to spread out. And then the shift V is probably, let's see, okay, that's 3. So actually the shift V might be 2. And the shift U might be 3 or something like that. Let's see. Okay, so I have to actually draw the second one for the second hexagon that's right there. So let's do that. 1, 2, 3, 4, 5, 6. Close it and then right click. Okay, and now let's play with the shift to kind of try to get it right. All right, that looks right. So the shift U is 2, the shift V is 4, which means, you know, this versus this, it's moving 2 units across before it starts to propagate the next pattern. It's moving 1, 2, 3, 4 units before it's trying to copy the next pattern. And that's what that should look like. So this is done, except I want to change the name here, right? So instead of PD whatever they gave you, I want to click here and say hex pattern and enter. And enter. Okay, so we're done. Now let's do a normal sort of PT panel grid. Select this, enter, base surface, and when you click on the pattern, you'll see my hex pattern has popped up right there. All right, and that's the hex pattern we just created. Okay, so as you can see, this grid, you can expand it, make it much larger. The basic idea is that this is a way you can actually create your own custom repeating patterns. And the hexagon is kind of like one of the more obvious ones, and that's why I'm kind of showing it to you here. So that's what you get if it's the sort of normal hexagon pattern, is that's what you see here. Okay? Now, if that's what these two are, so these two commands, this is the PT swap grid UV. If I swap it and enter, so that it already ran the command, right? So let's do a PT panel grid, select this, enter, base surface. So you'll see immediately it basically kind of reverses, swaps the UV directions of the surface. So what originally was going in the horizontal for these hexagons has become a vertical one. Right, so if you compare these two groups, then it's obvious. Basically, it flips the direction of the panels of the paneling. Now, the last option, PD direction, is a more sort of advanced version of it, where you can basically look at, okay, you know, that's the corner where it starts. So if you click on U reverse, that'll put it to the other side. If you click on V reverse, that'll put it to the other side, right? So it's sort of the same thing, except you have more granular control over whether or not you're reversing the U or reversing the V or both. Okay, that's what that command is for. Okay, that's simple enough, and this is just the sort of planarized output version of that, or this. All right, so that's the sort of creating your own custom 2D patterns, which can be very powerful if you eventually sort of like start to mess around with that. Now this is a kind of version of a 3D one. So PtOrientToGrid, and you can basically pre-draw a module like I have here, right? So this is basically kind of open-ended, crossed sort of tube, right? Enter, and it asks me to pick a module origin point. Okay, so the origin point is the lower left here, X direction, and that's why I drew this sort of square around it to kind of define the boundaries of the module. So this is the X direction, this is the Y direction, and a fourth reference point. So if I just skip it here and say enter for rigid orienting, you'll see what happens. So now I enter and then asks me for a grid. Okay, so let's say that, right? Enter a base surface, and it basically takes this and deploys it or arrays it, but things intersect, right? It doesn't really actually change the size or shape of the module. It just sort of arranges them into it, if you will. Okay, so that's not, that's just like what the sort of rigid orientation does. But if we do that again, module objects, enter, origin point X, Y, and for the last one, the fourth reference point, if you put in the diagonal here. Okay, this diagonal, so you can see a little better, this diagonal, and then we select a grid. Enter, base surface, or if you want to flip, the direction, base surface. Enter, then it'll calculate for a while. This is a much heavier calculation, by the way. So you'll see that this version actually takes it and morphs and sort of squeezes. You'll probably see a little better here, right? It'll squeeze those units. Let me select new, move them to the side, just so you can see it a little better, right? Now the cool thing, nice thing about it is that the seams, right? The seams between the modules they match now. They're basically adjusted in all three all three dimensions, X, Y, and Z, to make sure that the geometry will fit, like they will match each other, and eventually if you close this, then this will become a sort of watertight construct. Okay, so you can also imagine that you can actually play off of this to create another, a lot of different varieties of patterns, as long as they kind of fit within this sort of more sort of square-ish patterning logic, right? And you can actually get it to morph or fit to a non-sort of uniform frame. So you have smaller units, larger units, but they will all be sort of watertight like this. And obviously you can join them all together and cap the ends, and it will be a solid. So this join might take a while. Okay, and then let's cap. So the cap doesn't always work for everything, as you can see, depending on whether or not those edges were, flat or not. Right. But probably at this point, like the easier solution is just sort of try to trim the edges as a sort of planar edge to be able to close them. All right, but that kind of shows you some of the possibilities, but also as well as the sort of limitations. And that's it for this video. All right.